So for this one will be implicit differentiation. So when I derive this, right, it's basically we're going to find the coordinates of the two stationary points. It's where the curve will basically flatten out and where the gradient will equal 0. So we need to make our derivative, our dy dx, equal to 0. Alright, so I can get dy dx equal to 0. That would be my objective. And then I need to find x after that. So getting dy dx using implicit differentiation across the board means I'm firstly going to derive everything with respect to x. So I'm going to go d dx of each component in 2x squared plus d dx. We got some product rule coming in here. There's two functions in there. d dx of y squared is equal to d dx of 6. d dx of 6. And this is going to become 6x plus, if I make this u and I make this v, I know u dash equals 2 and v dash equals 1 times dy dx. So quickly I could do that and say, well, u dash times v plus uv dash would become 2 times v, which is going to be y, plus u, which is 2x times v dash, which is dy dx, plus d dx with respect to that will become 2y multiplied by dy dx equals the derivative of 6 is 0. So what have I introduced now? I've introduced dy dx, which gets me close to that spot, and there, making that the subject of the formula would help me now. So I got 6x plus 2y, which I can actually move onto the right-hand side of the equation, right? So I'm going to move this whole 6x and 2y all the way to the other side. I can also divide everything by 2 first. So I end up with 3x plus y plus x times dy dx plus y times dy dx equals to 0. And I'm going to move these guys across and take dy dx out, giving me x plus y equals to negative 3x minus y. And then divide both sides by x plus y. And so therefore dy dx will be equal to negative 3x minus y over x plus y. And so now I have my dy dx. I can now obviously make that equal to 0. Right? And if I make that equal to 0, then 0 will equal 3x minus y over x plus y. And the only way this would be 0 is if that is 0. So if negative 3x minus y equals 0, therefore y will equal negative 3x. Substituting y equals negative 3x into the equation gives me the x value. Okay, because I know what the y value is now, which means that if I change y up here into negative 3x, then it would be, I will be able to work from there. Okay, so let's have a look at that. So I'm going to take, I've got 3x squared plus 2x multiplied by negative 3x plus negative 3x whole squared equals 6, because this came from the original function 2xy plus y squared equals 6. And so that gets me, this comes down to 6x squared equals 6x squared equals 1. Square root both sides, x equals to plus minus 1. And now that I have my x components, 1 and minus 1, I can substitute that to get my y components in the original function as well. So I substitute x equals to 1 in the original function, from here to get my y value. This will be 3 plus 2y plus y squared equals 6. And if I have to calculate this component over here, alright, substituting that in there, that's going to become 2y squared plus y squared equals 3, or y squared plus 2y squared minus 3 equals 0. And I can then factorize y 3, 1 plus minus. And so y equals to negative 3, or y equals to 1. Okay. I do exactly the same thing when I substitute x equals to negative 1 in there, and I get 3 actually 3 minus 2y plus y squared equals 6, and so that becomes y squared minus 2y, and if I move 6 over, it's going to become 3 minus 6, which is negative 3, and so that becomes y minus 3 plus 1 when we factorize that. Y equals 3, or y equals to negative 1. So we want to find the coordinates of the two stationary points. We actually have quite a few points here. In the first case here, we can have 1 and 3, or we can have 1 and negative 1. And in the next case, we have negative 1 and 3. We can also have negative 1 and negative 1 as components from here. This is actually negative 3 over here. Yeah, so it's negative 3. Alright, the solution that we have at the moment is going to be that one. Alright, so we just got to now think, okay, well, why would these solutions be invalid? Or are they valid? Okay, the coordinates of the two stationary points on the curve. Why would these be not applicable? Over here. So what I could have done here is I went the long way, right? We also knew that from our previous calculation that we ended up with y equals negative 3x. So simply put, I didn't have to use the entire expression. I just got to use y equals to negative 3x. And you'll find that those are the two solutions that we've come up with. Alright, instead of the entire calculation. So going back onto this page over here, and having that and substituting a 1 and negative 1 in there, it's as simple as that. 1 goes in there, it becomes negative 3, negative 1 goes in there, it becomes positive 3. So those are actually the two components that we're looking for from there. Alright. Okay, we'll stop there.